is TWIS. Hey, Justin, can you turn down your monitors? I is hearing me. This is TWIS. This Week in Science, episode number 515, recorded on Wednesday, May 20th, 2015. Being right in a left-handed universe. Hey everyone, I'm Dr. Kiki, and this is This Week in Science. Today we're going to fill your head with a fancy bit of yeast, a reason to drink coffee, and... But first...
Disclaimer, disclaimer, disclaimer! Throughout human history, humans have assumed many things about the world, the universe, and our place in nature. We humans created stories of creation, stories of heroic battles with supernatural beasts, and stories of gods who watched from on high, judging mortal strife and triumph with great immortal interest. We cast ourselves as chosen, as children, as champions, as caretakers, and as cosmically challenged. Throughout human history, the stories we have told did much to mold our philosophies, our societies, and our language. How we think, how we act towards one another, and the way in which we speak is only partly based on being human animals. Much of the behavior of the wild bipedal ape beast is still with us, but the rest we invented for ourselves. And as far as this combination of wild and whimsical has taken us over tens of thousands of years, one thing added to the mix taking us much further, much faster. Science! By adding the rational application of the observed world to our wild and whimsical ways, we humans have transformed a planet that not long ago was our mysterious master. We are storyteller could have imagined. Not all of us have taken this third step in human evolution, as beast-brained humans fuel on myth abound in every corner of the globe. Yet together, week by week, we can take a few more along with us on the journey to the future, but by providing science for the masses. Here on This Week in Science, coming up next.
I've got the kind of mind I can't get enough. I wanna learn everything, I wanna fill it all up. Discoveries that happen every day. I know what's happening, what's happening, what's happening this week in science. What's happening?
Blair.
Good science to you, and Blair, and everyone out there. Welcome to another episode of This Week in Science. We are here to talk about all sorts of cool science stories that happened to come out in the last week. And we have got some great ones, some doozies, some new ones, and some revisitings from stories of the past. The stories that do not die, that live upon the young. Oh, wait, yeah, anyway, teasing a little bit. I've got stories this week about opiates from yeast, non-adaptive or ill-adaptive evolution in a few species of animals, and a left-handed universe.
I have got ED. I've got the mystery surrounding the oldest tools. As in, whose tools were they? And I have good-smelling dinosaurs.
Nice-smelling dinosaurs? Like perfumed?
Like, yeah.
Awesome. All right, everyone. Let's jump in right from the top, shall we? Why not? Why not? Opiates. Opiates. They're a problem when it comes to addiction, but they are wonderful when it comes to the many drugs used for controlling pain in the medical industry these days. Researchers have been trying for years to find easier ways to... I'm trying to balance my desk here. Okay, anyway. Researchers have been trying for years to eat or recreate the opium morphine creating pathway that exists naturally within poppies and put it in other like yeast. And so over the years there have been a few steps here and there that have been recreated, but finally it kind of is, the whole thing is being put together, which is pretty amazing. Like all of the steps are finally getting lumped together. And this could be great for simplifying the process, making it a little bit more lab friendly, but it also could make it a lot easier for backyard or garage chemists to create their own morphine, and for morphine to become more of a problem than it currently is for addiction. Currently is for addiction. So anyway, I'm going to bring up a little picture here, share the strain of yeast that's been created. So the strain out of multiple other species, multiple other organisms, and stuck them into yeast so that all of the steps, these metabolic steps, happen in the right order. A couple of steps. So the starting ingredient, which you would not necessarily think of when you think is glucose, codeine or morphine. The starting ingredient is glucose, sugar, and turning it then into something called norladinosyline, and then taking that ingredient and turning it into reticuline. That occurred back in 2008. Now, but researchers just did that. Glucose then was turned into this reticuline stuff. And so the next step is a step where the final ingredient thebaine is turned into actually codeine or morphine. There's a green, and there is another group out of Canada. There's a group out of Canada that has taken this step and done this step. And so now nobody's actually done it yet, but somebody taking these two pieces and just sticking them together into a single strain of yeast. Researchers are pretty concerned, and the publication in Nature actually led to a pretty quick write-up, basically saying, hey, this is awesome, but you got essential considerations. There are things that need to be recommended for consideration, and they're recommending that the engineering should be taken care of, that potentially yeast strains should be designed to make them less appealing to criminals. So the strains could be engineered, according to this commentary, to only make opiates with limited street value and not actually health. Of screening of the yeast and the sequences for the providers. And then security. Is there any kind of security that can be added to controlling the yeast that produce the opiates? Physical security or actual locking of laboratories, and regulation. Is there something that should be done to cover this new processing of opiates that is going to be for use in the medical industry under the U.S. Controlled Substance Act? So is there something to make it to make the release and distribution of these particular opiates illegal?
Right. So that's kind of along the same lines as we've talked before about when papers come out that could potentially help someone with biological weapons.
Yeah.
So it's very easy to kind of publish these things in the spirit of having science available to everybody, but also have information that's out there that maybe it's not so great that it's out there for everybody.
Right.
So where is that fine line? Where is the line where you want to share all of your findings, and it's best to be able to share that freely and without any sort of roadblocks, but at the same time make sure that there are safeguards to keep weapons or drugs off the street?
Yeah. Yeah. I mean,
That's one way to think about it, right? The other way to think about it is there is the counterpoint to always something when it comes to drugs is, right now, because of making drugs illegal, so prohibitive and so heavily enforced and investigated within this country, and that the only places where these drugs really come from now are through very, very, very powerful drug networks, right? Look at very powerful drug networks. Look at the backbone of a lot of the drug lords where the radicalized Islam terrorist attacks have emanated from. A lot of that is fueled on the opium trade. So there is some aspect too of if the cat did get out of the bag and there were trailer park opium labs or however you want to categorize them, right? Whatever you want to call them, where people are I don't necessarily think that by itself creates the drug problem, but it could reduce the amount of funds going to people who've been making a living off of it, being in rural areas and controlling the population there.
Yeah.
Rural areas and controlling the population there.
Kind of coming out of what you're talking about is that this is going to be readily available to anybody who can buy a homebrew beer kit to grow the yeast. So all you need is the yeast strain, or if you are a biogeneticist or biochemist, to actually put the strains together appropriately, and you can do it use this DIY trailer park aspect. People can definitely do it on their own, and so that's what is there's a good side and there's also a really downside to it. So yeah, it's not going to help. It's not going to help addiction in any way.
No,
that's what it comes down to.
Moving towards a direction where we can all have access. I mean, everything from the 3D printer being able to print you a gun or restricted from it, to being able to make a narcotic at home. I mean, everybody can make beer at home, but who does it? Nobody. Why? It's legal, so it's controlled, and it's more convenient for most people to go to a liquor store than to just go to a liquor store than to just make it at home.
Yeah.
Or as a civilization, we all have more access to the prohibited things, the prohibited substance, the prohibited substance, the prohibited, and we're going to have to live in a society where people are choosing for themselves what they're going to be doing, and law enforcement will be less and less able to restrict access to these things.
Yeah. Anyway, moving on from questions of DIY science and drug production into questions of using the blood of the young to save the old. Wahaha! Anyway, we have reported on kind of the vampire the vampire study in which researchers sewed up old and young mice together, sewing together their circulatory systems, finding that the blood of the younger mice was able to rejuvenate and almost reverse aging in the older mice. And one particular protein has been over and over. It's called GDF11. There have been many papers about it, 2 of them in Science last year that we reported on. Now, a Novartis Research Center is challenging that. They have a paper that just published online this week that is casting doubts on the whole idea. Researchers say that the GDF11 levels are not persuasive, and they appear to conflict and they are in conflict with the current researchers from Harvard who have been working hard on the GDF11 front. The Harvard team says they remain convinced that at least one form of GDF11 declines in blood with age, and that maintaining GDF11 levels in appropriate physiological range is essential for muscle health. And there are a few differences between the studies that have been done. The researchers at Novartis ended up using lots more of the GDF-11 than the Harvard group did, and the Harvard group is like, hey, this is a dose-responsive protein. You put too much in there, and you're going to see potentially negative results compared to what we found. But the researchers at Novartis counter that they had to use that much because they didn't get any response at all at the levels that the Harvard team used. So using specific tests from the Novartis group found that the GDF-11 levels actually trend upward with age in rat and human blood, and GDF-11 mRNA rise in rat muscle with age, which is completely opposite to what has been reported by the group out of Harvard. Harvard reported in their science paper that GDF-11 treated a damaged leg muscle with, they damaged the leg muscle with snake venom toxin and then used GDF-11. Regeneration was impaired. And so Novartis' group is saying, hey, GDF-11 seems to be harmful to muscle. What are you guys talking about? So anyway, there are, in this new study, a lot of questions raised as to whether or not GDF-11 is the protein in the blood that's having the effect. Researchers are still in agreement that there's something in young blood that is helping old bodies and brains, but this calls into question a particular protein that has been hailed.
This is kind of this almost seems like a different tact than I recall the original blood studies being. I recall it being more that there was a sort of a toxic buildup in old blood, and that by flushing with the new blood, it was more about not having the junk in there. It was about starting with a more efficient blood to begin with. Basically, I mean, the actual components that were doing the job, I guess, is what they're trying to drill down here, and somehow came up with very different results. But I think you nailed it right there. It's maybe the first study wasn't isolating it down as much as they should have to have known as much as they should have to have made the conclusion of what was doing the job.
Exactly. GDF-11 because it's very, very similar to another protein called myostatin, and myostatin controls muscle growth. So it is very possible that there was some confusion in myostatin versus GDF-11, or maybe the tests that researchers have been using to identify GDF-11, like you said, are not specific enough, and maybe there's another form of GDF-11 or a GDF something, but not the right one. Yeah. So,
but regardless of what's actually doing it, yeah, you need to get young blood transferred in and take your old blood out. Yeah, that part blood out. Yeah, that part of vamp is unchanged.
It totally is totally
isolation of exactly
how people thought about humors, and how that was part of the reason they would do things like bloodletting or other things, is because they were worried you had bad humors and you needed good humors and all this kind of stuff. And those humors are really just proteins or diseases, and we're figuring out what they are now. But if you look back, a lot of it is pretty far on the nose. Like, I know that they did talk a lot about old blood and young blood back then. Yeah. And so humors are actually just proteins, and we're figuring out what they are now. I think it's so cool.
Well, that's if we're assigning it to a specific thing. So the other part of that good blood, bad blood was they would try to get the bad blood out if you had bronchitis. I mean,
you're right.
If you had bronchitis. I mean,
you're right.
It wasn't necessarily like they isolated it was a blood transfer. It was just their answer. Leaching was their answer for everything.
At a time. But the humors thing was before that and after that too, and you read about the humors, and I think it's very interesting. There's a lot of stuff in there that they were just so close but not quite. They were just so close but not quite.
So close. Yeah. You know what? It's time for Justin to tell us a story. We're close to that.
Huh? What? Huh?
What you got?
Story that we've covered all year. Because there is a multi-bazillion dollar industry, that is dedicated, I mean, just in advertising, they're spending $1 billion a year or more. So the product itself must be making much, much more revenue than that. And of course, I'm talking about erectile dysfunction pills, which seems to, like, the more you see it, the less it seems to be marketed at dysfunction and more at just you should always, always be erect. If you are a male in society, there is no erect penis during your day where you should not have an erect penis.
That's
It
funny.
seems to be the
Oh my goodness.
be able to save some money and be able to maintain erections throughout the day. This is results of a study published recently in PLOS One found that men who consumed between 85 and 170 milligrams of caffeine a day, which is like what, 2 or 3 cups of coffee a day, percent less likely to suffer from not having an erection 24 hours a day.
Order.
Yeah,
Wow.
4% less likely.
Weird.
And if they bump that up, if they drink between 171 and 303 milligrams of caffeine, they were 39% less likely to. They were 39% less likely to improve your number. But still, both of those are significant compared to a population that doesn't drink coffee. Actually, that might be the flaw in this study. I don't know what percentage of the population doesn't drink coffee every day.
It's a fair amount.
Okay. Well, whoever they, so basically, if you don't drink coffee, you're more likely to get erectile dysfunction. You're more likely to get erectile dysfunction. Is which perspective you take, but you're increasing your odds of having erectile dysfunction by not drinking a couple cups of coffee. You're reducing your odds by drinking, however you want to look at it. What's interesting too is this trend continued among people who are overweight, obese, and hypertensive as well. First, sort of looking at the study was that, well, people who have hypertension might already be not drinking coffee, right? Or worried about their blood pressure getting too high or their heart rate getting too high, might already be avoiding coffee, and that might be the population that's left that's not drinking coffee, and therefore that's a population that has connections to ED. So, well, I mean, it sort of makes sense too, because we've also reported lots of times the benefits of heart health. On coffee drinkers.
Yeah.
Or making blood pass through your veins and your arteries, arterial passageways a little easier.
Or making regular. Maybe that has something to do with it.
Yeah, okay, here's it says that caffeine is consumed by more than 85% of adults, according to a different study.
Yeah, that's just caffeine. That's not coffee alone. So caffeine.
They're talking about caffeine. I've transmorgified it into coffee, because I wonder, I don't know.
So tea, here's a little, I pulled up a caffeine chart for you, Justin. So brewed coffee, 8 ounces, has 95 to 200 milligrams, depending on the coffee, because we all know some is stronger than others. You can make a stronger steep also. Tea, black tea, 8 ounces, 14 to 70 milligrams. So a really strong tea is as much caffeine as a weak cup of coffee. So it's still a fair amount of caffeine. I think you said, what was your low? It was 45 to 100 to 100.
So that's like I guess in your numbers 1 to 2 cups of coffee.
1 to 2. For example, 7.5 ounces has 24 milligrams of caffeine.
Yeah. So that's not gonna. You're gonna have to drink like a dozen of those sodas a day to get near the level. A dozen of those sodas a day to get near the level.
Half milligrams. Bull, 200 milligrams.
Yes. but you're more likely to lose your teeth because that's heavy sugar content.
Yes.
Heavy.
Come on. Erections, right? If you have no teeth, I mean, come on.
Oh my goodness. In the desert badlands of northwestern Kenya, found stone tools dating back 3.3 million years. I believe we covered this a little while ago when they were first announcing the discovery. The tool makers may or may not have been a direct human ancestor. These tools push back the earliest